Greetings to the viewers of this video. In this video, we are going to see how nitrogen dioxide molecule interacts with different radiations of electromagnetic spectrum, such as microwaves, infrared rays, visible light, and ultraviolet radiation. These radiations are arranged in an increased order of energy. First, let us see how a nitrogen dioxide molecule reacts with microwaves. Microwaves have wavelengths between 30 centimeters to 1 millimeter. They penetrate haze, snow, clouds, smoke, and are beneficial for satellite communication. Microwaves are the principal carriers of high-speed data transmission between stations on Earth. It is used to cook food, and also used in radar communication and wireless networks. Now, let us pass microwave on a molecule and see what happens. Are you excited? Let us go for it. Now, I am switching on the radiation source. The microwave is now passing through the nitrogen dioxide molecule. You can see the molecule obviously gets rotated. Microwaves usually rotate dipoles, hence the polar molecule nitrogen dioxide gets rotated, and thereby heat is generated. This principle is used to cook food in microwave oven. The waves are produced inside the oven by an electron tube called magnetron. Next is infrared rays. Mostly every object radiates infrared rays has wavelength in the range of 400 to 700 nanometers. Infrared waves are invisible to human eye. They are classified into near-infrared rays and far-infrared rays. The near-infrared rays is used in TV remote sensors and photography. The far-infrared rays are used in cancer therapy. Interestingly, human body at 37 degrees Celsius gives off far-infrared radiation measuring around 800 nanometers. Now, let us see how the nitrogen dioxide molecule reacts to infrared radiation. Now, I am allowing the infrared radiation to fall on this molecule. You can see the molecule is vibrating. Watch carefully, the bonds absorbs the radiation. It gets vibrated. And then, it is radiated back. The vibration of molecules would occur only if the molecule is polar in nature. When infrared radiation falls on the molecule, it vibrates in two different manners. One is stretching vibrations and the other is bending vibrations. In stretching vibrations, there is a change in interatomic distance along bond axis. And in bending vibrations, there is a change in angle between two bonds. Now, moving on to the visible light. All electromagnetic radiations are light, but we can see a small portion of this radiation, that is called visible light. Sun is the dominant source for visible light waves. Visible light has the wavelength in the range of 400 to 700 nanometers. Between infrared and ultraviolet. It is the only electromagnetic wave that is visible to the human naked eye, so it is named after that. Now, passing the light on the molecule, it is going through the molecule. Now, you can see the molecule is absorbing the light radiation. And after few seconds, it reflects back and goes to its initial state. When visible light is allowed to fall on a prism, we can see 7 colors from violet to red, Among this, violet has the shortest wavelength, around 380 nanometers, and the red has the longest wavelength of 700 nanometers. Now, moving on to ultraviolet radiation. Among all the radiations, ultraviolet radiation has the shortest wavelength, between 10 to 400 nanometers, and has highest energy of all. Now, let us see what happens when molecule is exposed to ultraviolet radiation. Now you will be able to see that radiation falling on nitrous oxide breaks the molecule into two halves. The one part goes as nitrous oxide, and other as molecular oxygen. As this radiation possesses high energy, the molecule gets broken into atoms. Ultraviolet radiations are used for sterilization of rooms and for analyzing chemical structure of molecules, and so on. Thanks for watching. Have a great day.